too difficult for us because it's pretty much all stuff that we've seen before with a couple new things added in. All right. So we're just going to keep talking about radicals. What's a radical again, y'all? Give me an example of one. Something. What does it look like?
1.
What?
Third.
What is this word radical? What does this mean? Say it louder if you know it. Like this symbol, yeah, class? Square root, cube root, fourth root. Remember these? All right, y'all. So radical expression. This is something that looks like square root of something. It's like square root of 4. Or sometimes it looks like cube root of a number, like cube root of 8. Okay, y'all. And then these two new things that we're going to learn about today. One is called radicalizing a denominator. So that's if you have something that looks like this, so like 1 over the square root of 2. Then to not write that with a square root in the denominator, which big ideas won't let you do, you'll take this times the square root of 2 over 2. And we can do that because what does the square root of 2 over square root of 2 simplify to if you were to simplify that?
1.
That's 1. It's like multiplying by 1. So it's not really changing the value of your fraction. Then, remember multiplying fractions, we multiply across. What's 1 times the square root of 2, class? Square root of 2. And then you're going to learn later today that if you take the square root of 2 times the square root of 2, that actually just ends up being 2. And we'll learn that today. So if you don't know for sure why that is, we'll learn about it today. And then conjugate, we learn about this in English or any foreign language class. In math, this means if you have like 4 plus the square root of 2, the conjugate is, you just switch the sign. So it's just 4 minus square root of 2. And that comes in handy in a couple of situations. And it'll show up if you move on and take college prep or calculus. Those concepts show up a lot. That's why we're going to touch on them in here. All right, and then I'm not sure where we're at in finding and simplifying square roots and cube roots, so I thought I'd give you kind of a cheat sheet here to help you figure out what the perfect roots are and what the perfect cube roots are. And what I mean by that is, hey, class, can you find the square root of like 3, for example? So like something times itself equals 3. Can you find a number that does that? No, so maybe something like that. Okay, but these are all the perfect ones. So what is the square root of 1? What's that equal to? What's the square root of 4?
Probably 2.
What's the square root of 9?
Probably 3.
Probably 3. What's the square root of 16?
4.
You kind of get where I'm going here?
Yeah, probably.
Yeah. Remember that square root, if we take the square root of 4, that just means 2 times itself, 2 is equal to 4. All right, you have that first one filled out?
Yeah.
Okay, how about cube roots? What's the cube root of 1?
1.
What's the cube root of negative 1?
1. Negative.
That is negative 1. And this is going to follow the same patterns. What's the cube root of 8?
2.
Because 2 cubed is 8. And then cube root of negative 8 is a negative 2. Cube root of 27 is 3. Cube root of negative 7 is negative 27 is negative 3. You can probably guess the pattern here. These will help you out as you go forward in this section. If you're ready, go ahead and turn the page.
Why do you have so much today?
All right, y'all. Putting a radical in simplest form. That is our first objective. A radical is in simplest form if no radicands, that's the number inside of the square root symbol, have perfect nth powers as factors other than 1. And we'll talk about what that means, okay? We don't have fractions in there, and then, okay, this is a rule for big ideas. I'm not too picky about this personally, but for big ideas to count your answers right, you will have to radicalize the denominator. So that means no square roots in your denominator. All right? So to do this, we can use the following properties. The product property of square roots. And this says that the square root of a product, so multiplication, equals the product of the square roots of the factors. Okay, what does that mean? This means that the square root of, for example, 4 times 9 is equal to, you can kind of break this apart into 2 pieces. And this will be separately the square root of 4 times the square root of 9. And you can do that too. All right, and then similarly, if you have things divided by each other, so if you have, for example, the square root of 4 over 9, this is the same thing as taking the square root of the numerator divided by the square root of the denominator, which this you have seen before. Square root of 4 divided by the square root of 9. So you can break this apart. What questions do we have so far? And then one more. If you ever do see a division sign, which you likely wouldn't, but if you see like square root of 9 divided by 4, this is the same thing again as square root of 9 divided by the square root of 4. So just like multiplication, we can break this apart into 2 separate pieces. The same rules do not apply for addition and subtraction, though, just for multiplication and division, okay? All right, and now we're going to simplify the following radical expressions. And this is what that first bullet point at the top of the page means.
This one is going to be 18.
18.
That's my best guess. It has to be less than 11.
Ah, okay, so this one might not be a whole number. And y'all, this is when breaking this apart into factors where one of them is like a square root factor is going to be helpful to us. What's that? Okay, do I have a calculator on these Chromebooks?
Yeah.
Where? My files?
Or no, like your
And then now go up to the little search bar there. No, don't go to your files.
No.
No.
Why did you go to your file?
Y'all told me to go. Oh, this calculator.
No. And then
Then go to where it says search your device apps, and then you can look up calculator.
Yeah, I'm about 6 seconds ahead of you over here. All right, y'all. Think about your perfect squares. We have 1, 4, 9. Is 108 divisible by any of those numbers?
9.
9. What's 108 divided by 9, class? 12?
Yeah.
Is there any higher number? Which one am I missing? Oh my goodness. All right, y'all. So let's do 9 and 12, okay? So this is actually 9
18.
and 12. That's okay. We'll do it this way. This is fine. 9 is a perfect square, correct, class? All right, but hang on, though. we can break this up further. Are there any perfect square factors in the number 12? What? 4. So this is really 9 times 12, which is really 4 times what, y'all? 4 times 3. So you see I'm breaking this into different factors? And then, due to our product square root property, we can take the square root of each of these factors individually. All right. And I'm going to rewrite this so that it's clear. This is equal to the square root of 9 times the square root of 4 times the square root of 3. What's the square root of 9? What's the square root of 4? What's 3 times 2? 6. And then square root of 3, that's not a perfect square, right? So we can just leave that as is. That means the square root of 108 simplifies to 6 times the square root of 3. So we pulled out all of those perfect square factors. All right, how about this next one? Maybe this one will be a little easier for us. 9 times x cubed. This is just like taking the square root of 9 times the square root of x cubed, right? Because they're being multiplied, so we can separate those factors. And then, what's the square root of 9, class? Okay, so this is really just 3 times square root of x cubed. And y'all, do you agree with me that this is really just x times x squared? That's what x cubed is. So this is equal to 3 times square root of x times the square root of x squared.
Is your second x?
It's 3 times square root of x times the square root of x squared. And now, what is the square root of x squared?
Probably x.
Just x. So this is really 3 times x times the square root of x. And that's how we can simplify 9, or the square root of 9 times x cubed. What questions do we have so far?
Kind of a lot. Where'd the square root go? Is it
The
not
square root of x squared is just x.
Okay, next.
Let's do some more examples. Square root of 24. Are there any perfect squares that are a factor of 24? Is 6 a perfect square? No, but what is
6 times 12.
4 a perfect square? Yeah, so this is really the square root of 4 times 6. And then due to our product property of radicals, we can split this up into the square root of 4 times the square root of 6. And what's the square root of 4, class?
That'd be
That'd be 2 times the square root of 6. And that's our answer. Because are there any other perfect squares as a factor that are factors of 6? No. So that's as far as we can go. All right.
Oh, shoot.
What? All right, next one. These just take a lot of examples and we'll start finding some patterns. So if you have any questions, just chime in, okay? Square root of 15 divided by the square root of 64. Let's start with that square root of 15. Are there any perfect squares that are factors of 15?
3 and 5.
Are either of those perfect squares? No. We actually can't simplify root 15 at all.
Why?
Because there aren't any perfect squares that are factors. 1, 4, 9 are our smallest perfect squares, and they're not factors. So we just leave this as square root of 15. Divided by Square root of 64. What is the square root of 64? 8. And you can write this as a fraction. Root 15 over 8. So that's what root 15 divided by 8 really is. It's all the same thing. And that's it for that one. That's as simple as we can go.
Did you make that?
Did I make what?
This one?
A problem?
That's fine.
Oh. Yeah, they don't connect, do they? That is weird. I don't know. All right, y'all. Can you guide me through this one?
No.
What's our quotient property telling us that we can do?
9.
All right, this says we can take the square root of 81, divide by the square root of x squared, right? And then what is the square root of 81? That's 9. And what's the square root of x squared? That's just an x. This is really just 9 over x.
Wow. I'm gonna do the next one.
You want to try the next one?
You have to take the square root of 9.
What is the square root?
7.
Okay, square root of 49 is 7.
Yeah. And then over that is 3.
Yeah.
Right.
So square root of 49 over 9 simplifies to 7/3.
Taylor can do the next one.
Cube root of negative 128. Do we know that one? No.
It's not on this page.
Darn. What are some of our earliest like perfect cube numbers though?
5.
Okay, so we got 1. 1 cubed is 1. What? 8. And 3 cubed is 27. Let's see if any of these are factors of 128. What's 128 divided by 8, y'all? 16.
So 16.
So 16 times 8 is negative 128. All right, so I'm going to say that this is equal to the cube root of negative 8 times 16. Hey, y'all, does 16 have any
4.
perfect cubes in it?
4.
That's not a,
I mean,
that's a factor for sure, but it's not a perfect cube.
8 does.
It is 8. So this is also equal to the cube root of negative 8 times 8 times 2. Because 8 times 2 is 16, right, y'all?
Well, 8 can be 2.
Yep. All right, hang on. You're one step ahead of me. I'm going to go ahead and split all these up to be the cube root of negative 8 times the cube root of 8 times the cube root of 2. All right, cube root of negative 8. What's that equal to? Close.
Negative 2.
Negative 2. What's cube root of 8?
2.
That's a positive 2. And then cube root of 2. We actually, that's not a perfect cube, so we just leave it as is. That's as simple as that one gets. And then to simplify this, one last step. What's negative 2 times 2, y'all?
Negative 4.
Negative 4 times the cube root of 2. That's as simple as we can get. What's that?
What do you use this for?
I still didn't hear the question.
What do you use this for? Like in
Oh, simplifying radicals shows up all the time, especially when you're dealing with finding the roots of quadratic equations. Remember, anything that's shaped like this or any motion that goes like this. Yeah. All right, how about this next one? Cube root of 125 times x to the 7th power.
Five.
Okay, we know what the cube root of 125 is. That's 5. So I'm going to go ahead and break this up. We know that the cube root of 125 is just 5. So I'm going to go ahead and just write that. Times the cube root of x to the 7th power. So remember before when we were dealing with square roots and we found that the square root of x squared was just x?
Yeah.
The cube root of x to the what power will just be x? What do you think? If we found that the square root of x squared was equal to x, the cube root of x to the what power is just going to equal x? 3. So we need to break this in terms of this x to the 7th power. We need to break it apart in terms of our x cubed factors. So this x to the 7th power, that's x cubed times x cubed times x. Do we know why?
No.
Remember that when you multiply an x to the something times x to the something times x, they all have the same base, right? When you multiply things with the same base and different exponents, you add the exponents. What's 3 plus 3 plus 1? 7. Okay, that's why this breaks apart this way. All right, y'all, so this equals 5 times the cube root of x cubed. I'm going to break this apart. Times the cube root of x cubed times x. Times the cube root of x. So I'm just breaking this apart. Cube root of x cubed times the cube root of x cubed times the cube root of x. All right, yeah. Now you tell me. You just told me. What is the cube root of x cubed? X. This is really just 5 times x times the cube root of x.
5x.
And then finally, we can simplify this to be 5x squared times the cube root of x. Can you do the last one on your own?
No.
Break this apart into cube root of 27 times the cube root of x cubed. What's the cube root of 27, class? What's the cube root of x cubed? Just x. This is just 3x. What questions do we have? We're all right. These take a lot of practice, but you'll be just fine. All right. And y'all, lastly, objective 2. Rationalizing the denominator. This just means get rid of the square root in the denominator. Okay, y'all, square root of 5 over 3n. Let's simplify this. Just to be square root of 5 over the square root of 3n. What's that? Okay, so rationalizing the denominator means that we're going to take whatever is in the denominator and use that as a factor. So we're going to take this whole fraction times the square root of 3n over the square root of 3n. Because remember that fraction, root 3n over root 3n, that simplifies to 1. So we're not really changing the value of this fraction at all. But this will make it just a little bit simpler. So square root of 5 times the square root of 3n. Using that multiplication property backwards, do you agree that this numerator just becomes the square root of 5 times 3 times n? Which is really just the square root of 15n. And then the denominator, square root of 3n times the square root of 3n. All right, y'all, this is just 3n. And I'll have a side note of why.
Because that's how it works.
That is how it works. If you multiply the same thing under the square root. All right, 3n times 3n. Root 3n root 3n times root 3n. Using that multiplication rule, this is really just the square root of 3 times 3, which is 9, and n times n, which is n squared, right? And then square root of 9 is 3, and the square root of n squared is just n. So that's why that works.
Math is just on a different level.
It's good to be able to be flexible with it, though. That's another reason why we're doing this. All right. 2 divided by the square root of 3. First things first, what do we need to multiply this fraction by to get rid of that square root of 3 in the denominator?
What?
Square root of 3 over square root of 3. Yeah. It's just whatever that denominator is. And then the numerator, 2 times the square root of 3, because it's just fractions, we just multiply across. That doesn't simplify at all, so this is just 2 times the cube root of 3. Sorry, the square root of 3. And then maybe can you tell me what is the square root of 3 times the square root of 3? That's just 3. There, and that's our answer. All right, y'all, these next two, we're going to use conjugates. And all you do is multiply by the conjugate to get rid of that square root in the denominator.
How do you know that you get these?
Because you see how we have a 2 minus a root 3? We have that subtraction sign there.
Yeah.
That's how you would know to use a conjugate.
Say that again?
How do we know to use a conjugate for these? That was the question. Do you see how this is like we have a minus sign in our denominator? If you see like a number plus or minus a square root of something, that's when you know to use a conjugate. You see that plus or minus sign? All right, y'all. And this means we're going to multiply by a fraction with the conjugate in the numerator and the denominator. And what that means is we're going to multiply by 2 plus root 3. And this is strategic, and you'll see why in a second. Alrighty, numerator. 1 times 2 plus root 3. That's just 2 plus the square root of 3, right? Divided by. Okay, and this is where our handy skills of foiling and distributing come into handy. All right, y'all, you ready for this? F, your first terms. What's 2 times 2?
2, 4.
4, right? Okay, we can do that. We can handle this. All right, y'all. Now take a look at these middle terms. We have a 2 root 3 with this one, because that's what 2 times the square root of 3 is. And then how about our middle terms? You see this is a negative root 3 times a 2.
I don't even know how you're about to do this right now.
So that's a negative 2 times the square root of 3. So those middle terms actually cancel out. Should I write that out?
So the 3's cancel out.
In a sense, yes. So we have, I'll write it out, plus 2 root 3 minus 2 root 3. And then our final terms, what is the square root of 3 times the square root of 3?
What's that number right there?
3. Right where, Becky?
The little numbers next to the 2.
Oh, no, that's nothing. I was just writing out what these factors were, but I decided to write it below, so. All right, y'all, our numerator stays the same, 2 over root 3. And our denominator, do you see any terms that might cancel out?
The 2 things.
Yeah, the 2 in the middle, these 2 root 3s. So these simplify to 0. And then we're just left with 4 minus 3. What's 4 minus 3? That's just 1, and anything over 1 is just itself. So this is just 2 plus the square root of 3.
Why is it so complicated? Where did that 3 at the end?
This 3 at the end, this is the square root of 3 times the square root of 3. Those last terms when you FOIL. Whew.
So are you always on foil?
Yep.
This thing? Okay.
Always FOIL with these things. So maybe I'll put that as a side note. We'll always have to use FOIL when we use conjugates. All right, y'all. This next one. Do we need to use conjugates?
Yeah.
Why?
It's a plus on the bottom.
All right, we got a plus on the denominator. So what is our conjugate of this one?
It's square root of 5 plus 6.
Square root of 5 minus 6. Because you just swap the sign. And y'all, the reason why we swap the sign is to get these two middle terms to cancel out. That's our goal. And that'll get rid of the square root in the denominator. All right, numerator. All right, y'all, I'm going to go ahead and say this is 2 times, don't forget parentheses on this one, square root of 5 minus 6. And then we'll FOIL to find the denominator. So, what's root 5 times root 5?
Oh, that's 1. 25.
Square root of 25, which is 5. And then what is root 5 times a negative 6? That's just minus 6 root 5. All right, and then FOIL, so we got a 6 times a root 5, so it'll be plus 6 root 5. And then a 6 times a negative 6, which is negative 36. All right, y'all, what do you notice about those two middle terms again? They cancel out again. So we're just left with 2 root 5 in the numerator. I'm gonna also, okay, is it okay if I distribute the numerator now? So take 2 times root 5 and then 2 times negative 6.
Yeah.
So it's 2 root 5 minus 12. Are we okay with that? And then, since in our denominator, those two middle terms canceled out, we're just left with a 5 minus 36, which is a negative 31. Whew, and that's the answer.
Yeah.
All right, we'll be okay with practice. But yeah, do you see this might be difficult because this does pull in a lot of old skills. For example, foiling, distributing. We're also talking about factoring things. So lots of old skills. All tying in together. Do we have any questions so far? Okay. We'll go ahead and move on to objective 3. Operations. I think you'll like these. All right, y'all. Radicals with the same index and radicand. These are words. All right. Index means like, is it a square root? Is it a cube root? And the radicand is just the number under the square root. So if you have the same number, so for example, this 5 root 7, you see this 8 root 7. So since they're both square roots and they're both 7, those are called like terms. We can combine those. So it's kind of like it's an x term. Remember if we would have like 5x minus 8x, that'd be a negative 3x. This is kind of the same idea. So do you see we have a 5 root 7 minus an 8 root 7? Okay, I'm going to say this is a negative 3 root 7. Do you see why? It's 5 minus 8. Plus the square root of 11.
If you do like, do you add those two?
Correct. Wait, which two?
5 negative.
Yeah, the 5 and the negative 8. Yep, so we took 5 plus a negative 8. In other words, 5 minus 8 to get that negative 3 root 7. And then this plus 11. Class, we can't combine these because this 11 and 7 are not the same number. So we can't combine these any farther. So we're done. And that's it. All right, y'all. 6 times the cube root of x plus 4 times the cube root of x. You see these cube root of x are like terms because they have the same number under the cube root symbol. So this is really just 6 plus 4 cube roots of x, which is 10 cube roots of x. These are maybe a breath of fresh air after the conjugates, huh?
Yes.
And this one is a little bit trickier, but I think we'll be okay. All right, y'all, do you see this? We can use the distributive property here. So we take root 5 times root 3, and then root 5 times negative root 75. All right. Root 5 times root 3. Should I just write that out just like that? Or do you want me to write out root 15? What makes more sense to you? That's okay with you? Okay. So this is root 15 minus, whoa, can I just write 5 times 75? Just for now.
Okay. Yep.
Because we can simplify this one a little bit farther if we wanted to. But square root of 15 doesn't simplify, does it?
No.
There aren't any perfect squares in 15, so that's done. There is a perfect square in 5 times 75. All right, y'all. This is really 5 times 5 times 25. Do you see this? No, it's not. What am I saying?
That's a great question.
75 is 25 times what, y'all? Yeah, I think quarters.
Money.
All right, so this is really just root 15 minus hey. Oh, yes, right there. Okay. In the white section.
grab you?
Admin Hugo. Sorry.
Sorry.
It's okay. Okay. Y'all. How flexible are we with these right now? If I just say this is,
Just break it all up.
can I pull out a 5
Go for it. Yep.
times the square root of 5 times 3, which is 15? Is that too many steps all at once?
I have no clue where you are. Okay, yeah, I know.
Where'd this 5 come from? Out front.
The long one.
The square root of 25?
Yeah, that one, right?
Pulled out to be a 5. And then where'd this 15 come from?
5 times 3.
That's 5 times 3.
Oh, okay.
All right, y'all. And the last step. Do you see how we have 1 times the square root of 15 minus 5 times the square root of 15? We can combine these like terms to be
4.
negative 4 times the square root of 15. That is 1 and minus 5. That is how I got that negative 4.
My brain hurts.
All right, y'all. Last problem. Ready?
Yeah.
The distance in miles that we can see to the horizon from our eye level, and our eye level is h feet above the ground or the water. It's given by this formula here. How far can we see when our eye level is 5 feet above the water? Well, this eye level is 5 feet above the water. What variable does this correspond to? H. So this literally means that we're going to find the distance that we can see when our height is 5. So that means our distance d is equal to the square root of 3 times h, which is 5, over 2. All right. So what's 3 times 5?
It's
15 over 2, right, y'all? All right. And if this helps you, square root of 15 over square root of 2. All right. How many miles is that? Square root of 7.5. Yeah. All right, y'all. How do you do a square root on this thing? Ooh.
Ooh.
So we want to do the square root of 15. Oh. Is it 15 over 7? No, it's not. 15 over 2. And then if I just click the square root symbol, does it automatically find that? Oh, cool. Oh, sorry, I accidentally clicked it again, but it's this number, right? All right, so 2.74 miles-ish. So this is about 2.74 miles. That's about how far we can see. Pretty cool, huh? All right, y'all. I am going to pass out a learning check for you that you can complete or you can work on in the next 5 minutes of class. And tomorrow will be a work day for you, all right?
What did you just say?
Yep, and I'll pass back your quiz. All right, y'all. Real quick, one last thing. I'm gonna pass back your quizzes. You can make corrections. Just put them on a separate sheet of paper. Make sure you have that reason why, or what you learned since this quiz. All right. Oh, I did good.
All right, everyone. Do we not have any more books? Oh. Guys, I got my glasses. Oh. Oh, I missed one. It's not like you got it. This is 10 minutes.
You can look anything, you're good. Okay. We're good, all right. Yes. What?
Is the follow?